Hello everyone, welcome to Unshackling Sudokus and Puzzles. I'm here to solve this bus Sudoku created by R. Kumaresan, an author who has contributed a lot of classic Sudokus to us in the past, and it has been a long time since we have covered a video on one of his creations. This Sudoku was created as practice for the upcoming Sudoku Grand Prix round at World Puzzle Federation. Round 1 is about to happen uh, at World Puzzle Federation, and it has been created by authors from Japan. You can expect a fascinating and tough challenge. This particular variant is the highest valued Sudoku in the contest. It has 110 points, and we thought of making a practice video for this Sudoku, and we thank Kumaresan for creating a Sudoku for us in short notice. So if you want to try this Sudoku out yourself, the link to solve is given in the description of the video. Please do give it a try and come back and watch the video. So the name for this Sudoku, Bust, you might wonder why it's called Bust, comes from the game Blackjack, a casino game where if you get more than 21, you are busted. So an idea borrowed from the Blackjack game into a Sudoku. So the rules are, let me just do Sudoku normal center. Okay. So rules are each row, each column, and 3 by 3 box of the grid will have digits from 1 to 9, no repetitions. And the variant part is a number x outside the grid is the minimum possible value for which the sum of the first x digits in the corresponding direction is greater than 21. Okay, should be easy to understand. So let's say we take this clue, 5 clue. This means that when you start adding digits along this direction, exactly at the fifth cell, you will exceed the total 21. Remember, it's exceeding the total. It doesn't mean that you can have 21 from these 5 digits. Exactly at this cell, you must have a total more than 21. And to make it more clear, let's say we consider this clue. If you start adding the digits along this direction, exactly at the fourth cell from this direction, you will have a total more than 21. So these are the rules. I have solved this variant in the past, and so I know a few tricks about this variant, which I think would be useful to share here. And I will share them through the uh, course of this video. But before that, let us do some classic stuff here, see if we have got anything easy to do. There is a 2 in row 2 and row 3. 2 goes in here. Nothing much with, okay, there is a 2 in column 1 and 2, so 2 goes in here. Okay, nothing much with the 2s. 5 in row 8, 5 in column 8. So that gives a 5 in one of these cells. 8 in column 7, 8 in row 6. So 8 is locked into these two cells. So notice that I'm only pencil marking digits which have two options. The clues are very sparse. It doesn't make sense to start writing center candidates at the start. 7 in column 2, 7 in row 2. So 7 has only two options. And I think that's about it. There is no digit that we can get directly. Okay, maybe 7 pencil mark we can just do a corner of 7 in one of these two cells. Okay, that's about it. So let's now start to look at the variant part. The first thing that I would like to say is when you approach this Sudoku, see if you have a clue 7 outside the grid. And the moment you see 7, it is just a bonus for you. You would rarely see this in the contest, I think. I don't expect to see a 7 clue in the contest because it's a dead giveaway. The reason is if you look at this clue, we know that at this cell exactly, the Sudoku is getting busted for this row, which means that the total is becoming 22 or more. But the thing to observe is the minimum sum of 6 digits in a Sudoku is always 21, neither less nor more. So, which means that all these 6 digits from this direction must be 1 to 6 in some order. If you substitute even one digit by a higher digit, then you will be busting the Sudoku at a cell which is much lower than 7. But it is exactly at this cell that we are getting a total more than 21. So which means the yellow cells must be 1 to 6, because the minimum sum of 6 digits in a Sudoku is always 21, right? So let me remove these colors now and write the pencil marks 1, 2, 3, 4, right? And now we can fill in these digits. They must be a 7, 8, 9 triplet, and that pushes the 2 into this cell, right? 2 goes here. Okay, we can do some classic stuff. 1 is removed from here, 2 is removed from here. So the remaining digits in box 7 are 3, 4, 5, and 6, right? Okay, 7 is in here, so 7 is removed. 9 is in here, 9 is removed. So I'm noticing something here. Okay, if you look at any row or column, I'll just show you. For example, this row, the outside clues always add up to 9 or 10. Well, this is not true for any bust variant that you will be solving in the future, but at least in this Sudoku, the author has constructed in such a way that the outside clues add up to 9 or 10 for a particular row or column. Let's just highlight the clues which add up to 9, for example. So these add up to 9. These along the column 4, 5. Yes, every pair of clues along a row or a column add up to 9 or a 10. The reason I want to stress this is I remember a trick that if you have outside clues adding up to 9, you can always make use of the fact that the sum of the digits along a row or column is 45. I'll tell you how. Let's say you take this row 6. Exactly at this cell, the 5th cell, let's say the cell marked in red, you will have a total more than 21 from this direction, from left to right. And when you look at from right to left, exactly at this yellow cell, you will have a total more than 21. Now, in any row, column, or box of a 9 by 9 Sudoku, the sum of the digits 1 to 9 is always 45. So, which means that if you have 22 from these 5 cells, then you must have 23 from these 4 cells, right? Because 45 minus 22 is 23. And if you have 23 from these 5 cells, 45 minus 23, you will have 22 from the yellow cells, right? Let me highlight that. That will be better. But suppose, let's say you have 24 from the red cells. 45 minus 24 is only 21. Well, by arithmetic, there is no problem with that. But as per rules, we are supposed to get busted at the 4th cell. Now, if you have only 21 from 4 cells, how on earth are we going to get busted? So, which means that when you have outside clues adding up to 9, the total combination must be 22 and 23 in some order. That's what I wanted to stress. So this is true for any set of clues, not only clues which have 5 and 4 in them. Let's say, for example, do we have 3, 6 somewhere? Okay, look at this one, 3 and 6. So which means that the purple cells add up to 22 and the orange cells add up to 23, or the purple cells add up to 23 and orange cells add up to 22. This is true for any set of clues, outside clues, which add up to 9. right? So this is the most important reduction, I would say, in the Sudoku. Now let's see if we can put this into good effect. We started with this row, right? Let me look at this row because you have 7 and 8 as part of the 5 clue. Now 7 and 8 add up to 15 already, and we know that we need to get to 22 from these 5 cells, 22 or 23. Okay, let me make that red. So which means that from these 3 cells, let me use some other color. From these cells highlighted in brown, we need to get to 7 or 8. 15 plus 7 is 22 and 15 plus 8 is 23. And when you have 7 or 8 from 3 cells, 1 is always part of the sum. And that means that 1 has to go here. What a beautiful reduction. 1 cannot be here, 1 cannot be here. So 1 would definitely have to be part of this sum, right? So if you have 22, this must be 2 and 4 because these 3 cells will add up to 7. And if you have 23, these 3 cells add up to 8, in which case you can have 2, 5, 2 and 5 here, or 3 here and 4 here, right? So these are the only combinations that you can get from here. Let me change this to red back. So this is red, this is red. So I got 1 here, right? Let me use some Sudoku. So 1 goes in one of these 2 cells. 1 is in row 4, row 6. 1 goes in here. 5 is in column 5 and column 6. So 5 goes in here. Now what do we do? So again, we have a clue which add up to 9. So which means that these 5 cells along column 1 must add up to 22 or 23. And correspondingly, these 4 cells must add up to 23 or 22, depending on whether these 5 cells reach 22 or 23. Can we do something here? Okay. Oh, that's really nice. So, in order to get to 22, we need to put all the maximum possible digits here, right? Now, the maximum possible digit that you can put in these cells is 8 and a 5, 6 pair. And if you add all these clues, you just about reach 23. 8 plus 5 plus 6 is 19, and 19 plus 3 is 22. So, which means that we need to put the maximum digits. Otherwise, there is no way we are going to get to 22. Superb. So, that is 8. That becomes a 5, 6 pair. And that's a 9 now, and that's a 7. Now, this is a 3, 4 pair. And now I know along column 1, the remaining digits, which must be 3, 4, 7. So you have a 3 here, that becomes a 4, 7 pair, giving us the 3 here. And 4, 7 can be resolved with the help of this 7, not a 7. So 5 is in row 1, so 5 goes in here. Oh, look at this clue, guys. This is superb. So these 3 cells, outside clues, remember that they add up to 9, which means that these 3 cells must add up to 22 or 23. But is 22 possible? Not possible. Because 22 has only 2 options. It's either 5, 8 and 9 or 6, 7 and 9. And both the options you can see are ruled out. So the only way that you can satisfy the 3 clue is if you have a 6, 8 pair here, which is 23. So these 3 cells add up to 23. And now you can place the 1 and the 5 in this box. So 1 goes here, 5 goes here. Beautiful. This is really nice. So 5 here, so that gives a 4 in here. So 3, 4, 5, 1, 2, 7. This must be 6, 8 and 9. 3, 4, 7 and 9, 1 and 2. So this must be 5, 6, 8. And you can't have a 5 in here, right? So that's a 5. And this 5 can be resolved now. So that is a 5. And if you look at row 6 now, 3 cannot be in these 3 cells, so 3 would have to go here, and that becomes a 269 triplet. 2 can't be here, 6 can't be here, and 9 cannot be here. Okay, 2 is in row 5, so that gives me a 2 in one of these 2 cells. Okay, 8 is in row 7 and row 8, so that gives me 8 in one of these 2 cells. Oh, this is really nice. Can you have an 8 here? I'll highlight that cell. Let's say we make it purple. Can you have an 8 here? If you have 8 here, what is the minimum sum from these 5 cells? You can have a 5 here. 5 plus 3 is 9. 9 plus 2 is 11. 11 plus 8 is 19. And 19 plus 7 is 26. So we are being busted at the 5th cell already, right? But we need to bust exactly at the 6th cell, not at the 5th cell. So which means this 8 is violating the clue. So this is not an 8. That has to be 8. Nice deduction. Okay, so let me remove the 8 from here. Look at this cell. It cannot be 2, 3, 5. It cannot be 7, 8, 9. So this would have to be 1, 4, and 6. Oh, this cannot be 6. And notice that the 6 in row 9 is in one of these 2 cells, right? If the 6 goes here, then 6 plus 5 is 11. 11 plus 7 is 18. 18 plus 2 is 20. 20 plus 3 is 23. So from 5 cells, we are already busted. So this is not a 6. That's 1 or 4. And now there is only one option for the 6. 6 would have to go here. And 5 goes here. And that resolves this 5, right? So that is a 5. And 5 in column 9 has only one option. 5 goes here. So along row 9, this becomes 1, 3, 4. Oh, this cannot be 4, guys. Superb. Superb. If you have 4 here, then what does these 5 cells add up to? You have 2, 3, 4 from these cells, which add up to 9. And 9 plus 6 is 15. 15 plus 7 is 22. Again, we are being busted at the 5th cell. So this cannot be a 4. This would have to be a 1. Oh, sorry. This would have to be a 1, which means this becomes a 3, 4 pair. So 1 is removed from here. So 1 goes in one of these 2 cells. Okay, there is a 2 in column 4, column 6, and 2 in column 4, column 6 of this box, which means along this column, 2 has only 2 options. One of these 2 cells, so that's not a 2, that's a 3, 4. So along this column, the candidates that can get into this cell are 4, 6, and 9. 1, 5, 7, 8, 2, and 3 are eliminated. And similarly, this would be 1, 5, 7, 8, 2, and 3, 4, 6, 9, right? So look at row 2. They add up to 9 outside clues, which means these 5 cells add up to 22 or 23. So I think we should be able to figure out the values here. 2 plus 4 plus 5 is 11. So which means we have 11 from here or 12 from here. If you have 11 from here, this would be 3 and this would be 8, and that is the only option. If you have a 12 from here, 5, 7, 4, 8, this would be 3, this would be 9. Awesome, guys. Superb deduction. Wow. Look at these 5 cells. We have 11 from here, so which means to get to 22 or 23, we need 11 or 12 from these cells. So if you have 11 from these two cells, it cannot be 2 plus 9. It cannot be 4 plus 7. It cannot be 5 plus 6. It would have to be 3 and 8. Only option. And if you have 12 from these cells, it cannot be 4 plus 8. It cannot be 5 plus 7. It would have to be 3 plus 9. Again, only option. So in both the cases, this would be a 3. So that removes the 3 from here. Now, oh, there is a 1 in here, right? So 1 goes in one of these two cells and 1 cannot be here. So that's a 1, that's a 2. 1, 2, 5, 6, 8, 9. So that is a 3, 4, 7. Triplet, 3 cannot go here. That's a 4, 7. Okay, 3, 4, 7, 2 and 5. So we need 1, 6, 8, 9 here. 6 cannot go here and 1 cannot go here. So this has to be 8 or a 9. That's a 1, 6, 8 and that's a 1, 6 and 9. So where do we go now? This row appears restricted because we have a lot of digits and pencil marks. So let's see if we can get something here. Oh, that's nice. 4 must be in one of these two cells, right? Let's say if you don't have a 4 in either of these cells. Let's say this is a 6, 9 pair. Now if you add all these 5 cells, 5 plus 3 is 8, 8 plus 6, 14, 14 plus 1, 15, 15 plus 9 is 24. So we are busted already in 5 cells. So it is certain that now 4 must be in one of these two cells for sure, which means this is not a 4, that's a 2. This is a really beautiful construction, an excellent practice Sudoku, I would say. So 2 is removed from here, 1, 3, 4. So we have a triplet that becomes a 2, 7 pair. And that is not a 2, that's 4, 6 and 9, and 4 is already here, so that's a 6 and 9. Oh, you can't have a 9 in these two cells. Again, 1, 3, 5 is 9, right? 1 plus 3 plus 5 is 9, and if you have 9 from these two cells, then 4 plus 9 is 13. 13 plus 9 is already 22, right? But we need to muster the sixth cell only, so this must be a 4, 6 pair. Superb, that's a 4, 6 pair. That would have to be a 9 now. This becomes 3, 4, 6. This is getting interesting. Okay, 3 is not here because of the 3. So 3 is in one of these two cells. You can't have 3, 6 in here. Beautiful. Look at this 5 clue. We have 3, 5, 8 already, which means we get to 16. And if you have 6 in these two cells, 16 plus 6 is 22, and we are busted in 4 cells already. So this cannot take a 6. That's a 6. That becomes a 3, 4 pair. So 1, 7, 3, 4, 5, 8. So this would be a 2, 6, 9. 2 is eliminated here. 2 is eliminated here. So that would be a 2. There is no 2 here. Okay, this is a 4, 8, 9 pencil mark. 6 is in one of these two cells. So 3, 5, 2, 6, 9 and 1 and 8. This would be 4 or a 7, right? Can't be anything else. So if I have an 8 here, oh, I'm seeing a complicated deduction here. You can't have an 8 here. So let's say we have an 8 in this cell. Now the 8 in column 9 is forced into this cell, right? Now these outside clues add up to 9. So which means from these 4 cells we get either 22 or 23. And we have 13 from 2 cells already. Which means these 2 cells must add up to a 9 or a 10. They can add to neither. If they add to 9, you need 4 and 5 here, but 5 is already here. And 7 and 2 is already ruled out because of the 2 here. So 9 is not an option. Can it be 10? 4 plus 6, but 6 is already here. 7 plus 3, 3 is already here. So if you have 8 here, 8 gets posed here, and both 9 and 10 are ruled out as options. So that's not 8. So 8 would have to be here, if I'm not wrong. Tough one. Maybe there are better ways to continue Sudoku at this point, but I'm using this deduction. So this is not 8, it's 1 and 6. And that 8 is superb. It resolves this triplet. That gives an 8 here, gives a 6 here, a 9 here. That resolves this 6, 8. This should be 4, 7 for the row. This would be 1, 4, 7. The 3 here removes the 3 from this cell. That's 1 and 4. So what do we need to look here? Okay, you can't have 7 here. Look at this clue. If you have 7 here, 2 plus 5, 7, 7 plus 8, 15, 15 plus 7 is 22. We are already busted in 4th cell, but we need to bust at 5th cell. So 7 goes here. Oh, that's a 4. This is not a 4. That becomes a 1, 7 pair. And this would be 4, 6 and 9. 6 is not here. That's 4 and 9. Okay, now the 4 is helping. So you cannot have an 8-9 pair here. That means 4 must be here. Because if you make an 8-9 pair, then 2, 8, 9 is already... Oh, well, you can have an 8, 9 here, right? You can have an 8, 9 here. I was actually thinking that it's getting busted short of the clue. Maybe let's come back to this clue again. 8 plus 5 is 13. So we need a 9 or 10 from here. 10 is possible, 4 plus 6, but 9 is not possible. Super. You cannot have 9 from these two cells. 4 plus 5, 7 plus 2, both are ruled out. So only option is 10, so which means it cannot be 7 and 3. So that's 4 and 6. Which means this is 2, that is 9, that is 6, that is 7, that is 2, that 4 gives a 1 here, a 3 here, a 4 here, a 3 here, 4 here, 3 here, 4 here. Superb. Excellent practice Sudoku by Kumaresan here. So this becomes a 3, 7 pair. So 3 is in here, which means that's a 3, that's a 7, that's a 7, that's a 1. And this column can be completed. So that's a 9, that's an 8, that's a 1. This 9 gives me an 8 here. And this is not an 8, that's a 4 and 9. So we just need to resolve these digits. And how do we resolve them? Okay, look at this 6 clue. 1 plus 5 is 6, 6 plus 6 is 12, 12 plus 3 is 15. And if you have a 9 here, it's getting busted in 5 cells. So this would be a 4, which means this is 9, that is 6, that is 4, 6, 9. And with that, we have completed this tremendous Sudoku created by Kumaresan. What a Sudoku. Hope you enjoyed watching this video. The main tricks in the Sudoku are to see if you have an outside clue like 7, which is a dead giveaway and which I think won't be in the contest. But if you see clues which add up to 10 on the outside, remember that, I'm sorry, 9 on the outside, remember that the combinations will always be 22 and 23. Hope you guys do well at the contest. If you like this video, please give the thumbs up and remember to subscribe to the channel. We hope to see you soon with a video. Bye bye.